Hi, I'm Phil from Simply Rhino, and in this video series we're going to take a look at creating this engine cover with the aim of eventually creating a solid model that we can export from Rhino into SolidWorks to add parametric features. The initial aim is to create some reasonably good surfaces that define the overall form and individual transitions with a good deal of clarity. In this first video, we're going to quickly examine laying out 2D and 3D curves to create the basic slabs that we see here, before moving on to look at creating the main blends and in particular this slightly difficult front corner transition. Going back to the overall geometry, the shape around this front corner is less than ideal for a smooth result. And we've done this purposely so that we can look at the methodology we can use in these real-world situations where we need to build smooth transitions on geometry that doesn't really fulfill an ideal. Let's take a look at how we can lay out some curves in Rhino that are going to define the boundaries of the main slab surfaces that we're going to work with. Whether we merely draw these curves in Rhino or we trace them over an imported bitmap reference, the starting point would generally be some 2D curves that we can then arrange in the appropriate 3D space. Therefore, we can fairly easily create the three-dimensional boundary of the engine cover. Here we're only creating half of the engine cover because of the fact, fairly obviously, that it's symmetrical about its center. And this idea of laying out the curves and techniques that we can employ to do this is something that we cover in quite a lot of detail in our intermediate advanced class. So once we've got our 2D curves in position, we can gradually start to add some of the interior curves, and again it would make sense for these to be created initially as two-dimensional curves. Eventually these curves would need to be optimized or rebuilt, and here all of the curves are going to be built as degree 5 curves with 6 control points. And as well as giving these curves the same number of control points, we're also going to employ another technique here. If we were to look at this curve here and this curve, these two curves represent essentially the same curve, which is this curve at the highest point of the engine cover here, and we're seeing it either in its right view or in its front view, depending on which curve we're looking at. Now if we turn on the control points here, you'll see that these control points are aligned along the world Y axis, and this is something we can do to make it easier to build good three-dimensional curves. Generally speaking, to build these curves, one technique might be to build one of these curves, and then rather than to draw it again in the right elevation position, merely it's a case of copying the curve, orienting it about the correct construction plane, and then adjusting the control points, in this case vertically, to arrive at the correct shape. And when we do this, we can use tools like the curvature graph to assist us with the shape. So gradually we can lay out some two-dimensional curves, and we can also gradually start to take some of these curves and push them onto another layer where we're going to create 3D curves. So of course that we know our boundary curves here that are existing are going to be part of our final 3D layout. So we can copy these curves onto this new layer, and let's copy the high point curve, which is this curve and this curve that we've got expressed as two separate two-dimensional curves. Let's copy this over to our layer 2 here. Let's just change the object color of these boundary curves, and let's look at a technique that we can use to quickly generate the three-dimensional curve from these pair of two-dimensional curves. And this is to use the command called curve from two views. Okay, so in this case it'll generate the three-dimensional curve for us. Okay, now this command works by essentially projecting the two curves until they hit each other in 3D space, and as a result the curve that we generate here is much more complex than the original curves, and it isn't something that we can use directly in this case, but we can use it as a guide and to check that the position of our clean curve is correct. So the way that we can produce a clean version of this curve is to first of all run a command called extract points from this curve, and I'm going to lock these points, and then I'm going to delete that two-dimensional curve. I'm then going to turn on the control points for this curve, and working in my right view I'm going to turn on the project constraint and then take each one of these points and move them up to snap them on to my reference points. Okay, and we just have the curve from two views here just to act as a guide. So once we're happy with the shape of that, we can delete the curve from two views. We can unlock our points and delete those as well. And we can gradually start to create some curves. So we can use curve from two views as a quick way of creating the 3D curve, and then we can maybe go back through some 2D iterations until we get the desired result. And eventually we'll arrive at a set of curves that describes our layout. So each one of the curved curves here, so these curves here, each one of these is a degree 5 curve with 6 control points. And to build the surfaces from these, we can predominantly, I think, use sweeps. So we can use sweep to rails, and it's important when we use this command that we use the simple sweep option here. This disables any matching in the command, but what it does is ensure that where geometry permits, we'll have the same degree and control point layout as the contributing curves. And so we can just keep running our sweep to rail command here with the simple option until we've built our slab surfaces. Okay, so that looks okay. And then we can just create some planar surfaces. To fill in the rest of this. It's very often a little easier if we can make things into a solid at this stage. So join this together. And then cap to close off the bottom. Okay, now we've got a closed poly surface, and we can then move on to looking at the blended conditions, particularly around this front end. Now, it's a good idea at this stage to maybe start to sketch out what we want the fillet or the blend conditions to look like here. And we can do this quite crudely, but just working something out on a bit of paper very often is a much quicker way than trying to work something out completely on screen. So here's a quick sketch that's just been created by tracing over a print of the sharp solid that we've created previously, and you can see that the idea here is that we want to maintain a constant size of blend around this portion here, and then have a larger blend radius at this corner. And then we want to create a transition here. Now, of course, how we actually create this transition is the difficult point, but what we can see here is the clear intent about what we want to do along the main portion of these blends. And this kind of mimics the way that we're going to work in Rhino. We're going to build the known parts of the blends first of all, and then finish up with the transition. Once we have the slab surfaces and the sketch reference, we can start to add the fillets or blends. Here I have a closed poly surface or solid, and I'm going to use the solid blend edge tool. Because of the fact that we have 4 edges that all converge to a point, and that one of these edges will have a substantially larger blend than the others, then the geometry isn't ideal. This will result in the solid blend edge tool failing to complete, but we can use the surfaces that the tool does create as a starting point to build the troublesome corner manually. So let's start by going to Solid, Fillet Edge and Blend Edge. I'm going to choose a 20mm radius for these 3 edges, and then change the radius to 80mm for this edge. Then I'm going to enter to get into the preview mode. Now, the rail type that I'm using here is distance between rails. This ensures that if you take a perpendicular line from the setback of the blend to the other side of the blend, this distance will be 20mm. This keeps the blend looking the same as the angular condition changes from face to face. You'll see here that in the preview that the corner doesn't build, and really we wouldn't expect it to build given this type of geometry. So what we're going to do is to accept the result that we get and then to work into this manually. So let's take a look at what parts of the surfaces created by the solid blend edge tool we can keep. Most of the smaller blends are in fact okay, and if we look at these 2 surfaces here, they're fine up to the point at which their edges converge here. These 2 blends are in fact poly surfaces, and you can see that the blend has run into trouble where we've encountered the corner, and if we explode these poly surfaces, we'll see that we can just remove this front portion here. And I'm really interested, as I say, in these 2 blends up to the point at which the edges converge. Now, the isocurve direction here should be perpendicular to the blend edges, and therefore we can use the isocurve direction to split with. So I'm going to go to my surface menu and use split at isocurve and pick the first of these surfaces and split with an isocurve. I'm going to enable the shrink option and snap right onto the intersection here. When the shrink option is enabled, both of the surfaces that I obtain by splitting will effectively be untrimmed. And this idea of having an untrimmed edge here is very important in case we need to run a match surf command to it. So I'll now repeat the split at isocurve command on the second of the blends here, and I'm going to need to reinstate the shrink option here. This option isn't sticky, so be wary of this. And split again. Next up, I want to take a look at this larger blend. We won't really be able to use anything of the blend that's been created with the solid blend edge tool, but we can at least use this to generate a reference for the start of the setback for the blend. Before I do that, I'm going to take my closed poly surface and explode this, and I'm going to hide the portions of this that are not immediately relevant. So these three planar surfaces. And I'm going to look first of all at this front surface here. All the surfaces that we created for our main slabs are untrimmed surfaces, and so the isocurve direction describes really well the shape of the surface. So what that means is I can use that isocurve direction to create the setbacks with. So I'm going to go to Surface, Surface Edit Tools, and Split at Isocurve. Pick the front surface and enter. I'm going to enable the shrink option, and I'm going to snap this iso line back onto the start of the blend. And I can then remove the small piece of surface. Now, the blend edge on the side surface wants to run up to this point here on the smaller blend. So this blend here now is redundant, and I can again use split at isocurve, make sure that I enable the shrink option and snap to this edge, and then delete. And then finally I can go again to Surface Edit Tools and Split at Isocurve, and I can split this surface again where it intersects the front edge. Okay, now I can start to trim out some of the surfaces with the edges of the blend. So to do this, I'll use the trim tool, and at the select cutting objects prompt I'm going to type in CRV and enter. This limits my selection now to either surface edges or curves, and it means I can now pick the edge of this blend surface, enter, and then trim away the top part of the surface here. And I can do something similar with the side and this intermediate surface here. So trim, CRV, enter, pick these two edges, enter and trim, and then trim, CRV, and trim away this part of the curve. So next thing we need to do is to take a look at this large blend here. And we could either create some curves here and do a sweep, but it's probably easier to use blend surface here. So I'm going to go to surface, blend surface. I'm going to pick the one edge, enter, and then the next edge, and create a curvature continuous blend. Now I'm going to look at this in top view just to look at the shape of the blend, and I'm going to lock the sliders, and I'm just going to push out the blend shape a bit so it's not quite as flat. Okay. What I want to make sure doesn't happen is I don't want to get a sort of an S shape here, so I'll pull this slider back slightly, but I just want it to be slightly bigger than 1 here. Okay, so I may need to look at this with an environment map. Just to take a look at this shape to see how it looks. Okay, so assuming that we are happy with the shape of the blend, then one thing we may need to do here is just to make sure that the bottom of this blend is actually pulling down to the same depth as these two flat edges of these surfaces here. So to check this, what we can do is just extend this surface here by a small amount and then trim it back with a curve or a line. Okay, we do this because eventually our aim here is to make a solid from this and get the solid into SolidWorks. Okay, so that's our corner blend. Now we may need to come back and re-look at this corner blend, but for now we'll accept the corner blend condition here, and the next job now is to create this inside corner here, and we can do this with the adjustable curve blend tool by blending this edge and this edge together. We want to set the continuity here to curvature at both ends, and again we just want to take a look at this in the top view here, and just to take a look at the shape of the curve and make sure it sort of is empathetic with the shape of the top of the blend. That looks okay to me. Okay, so the curve that's created by adjustable curve blend will be more or less touching this top surface here, but it may be slightly off the surface. So what I'm going to do is go to curve, curve from objects, and pull back, and I'm going to use the pull back command to pull this curve onto this surface here. What the pullback command does is use the surface normal direction to suck the curve onto the surface, and with this command I generally have delete input option saying yes, because it's very hard to see sometimes which is the pulled curve and which is the original curve, because in this case the movement of the curve is going to be very, very small. Okay, so that curve is now on the surface. Now the downside of this is that we previously had a G2 continuity against this edge and this edge, and we will probably now only be tangent. So I'm going to check this by going to Analyze, Curve, Geometric Continuity, and picking the two edges, and indeed both of these now are only tangent. However, in this case that tangent continuity is good enough for me to build this corner reasonably well. So now we have that curve, I'm going to trim again and use the CRV input, pick this surface edge, that curve, and that surface edge, and enter and trim away. and then I'm going to select the curve and delete it. So I can now join this geometry together and take a look at this with the environment map tool. Okay, and just want to have a look at the sort of overall shape that we've got here, and we can take a look at this with the zebra stripes as well. Just to check that our blends have built correctly. Okay, so everything looks okay from that point of view. So we've got a reasonably good starting point now, and our last job is to build this troublesome corner. Now this may take some iteration, and one of the first things that we'll notice here is that we actually have 5 edges here. Now of course NURBS is a 4-sided topology, and we really need to work with 4-sided surfaces here. But there is a fairly sort of tried and tested method that we can use here, and there are a few variations on this theme, but let's look at just one of them. So what we need to do is to create a curve that is going to establish a 4-sided surface for us. Now perhaps the main driving factor in this shape is this outside edge here and how it comes round and wraps into this front blend here. So I'm going to go to my adjustable curve blend tool, and I'm going to blend this surface edge with this surface edge here to create a rail that we can use to sweep along. And again, I'm going to go into my top view here, and if necessary just pull this out slightly here. Now we're not actually going to use this edge of the surface in the final analysis, but we still need to get the shape of this correct. Okay, so we want to make this look fairly consistent when we look at it from top view. So we want to make this width from the curve to this edge look fairly consistent. So we'll accept that result, and then we're going to build a sweep. So we're going to use sweep 2 rails, and we're going to sweep against this rail and use that and that as the cross sections. And at point B here we're going to match for curvature continuity. So I'm now going to join the sweep into the rest of the shape and take a look at this with the environment map. And just take a look at the sort of shape that we're getting here. So the overall shape here, a bit difficult to see without environment map. Let's try this one. The overall look of this now looks pretty good. This corner, top rail of this corner looks fairly consistent as we come round here. The shape looks quite good. It has a good deal of commonality with this bottom shape, which is what we want. Of course, as we explained earlier, this is far from ideal, this corner transition, and we've really done this to try and prove that we can build a reasonable corner out of a geometry condition that's not ideal. So the remaining part now is to fill in this area. Now again, if we think about the shape here, going back to the sketch, this area of course is also blending round to here. Now what we really don't want to lose is the high point of this surface here. So what we could do is take this edge and bring it round to the middle of this edge across here. to again give us a four-sided surface. So to do this, we're going to go to Curve from Objects and extract isocurve. And I'm going to take an isocurve. I'm going to toggle the direction first of all. I'm going to take an isocurve out of this long fillet here and snap to the midpoint. And then I'm going to go to my adjustable curve blend and run an adjustable curve blend around here. And again, I'm going to take a look at this in top view, and we want to kind of make sure here that our adjustable curve blend comes just inside this sort of middle of our existing sweep that we just created. So we'll try this to start off with. Now this curve of course is going to be at a different height to our existing surface. So I'm going to extract this sweep here and I'm going to trim it with the curve. So I'm going to trim in top view here. Okay, and delete the curve and just have a look at this just to make sure we haven't got anything too bad here. And you'll see what we're trying to do now is again to run a sweep along here, and the surface change here from this small dip to a small crest in the other direction isn't too big, so we should be able to hold continuity to the two long edges quite well here. So I'm going to join the geometry together here, just check my edges here just to make sure that this and this are closed up, and then I'm going to create a two rail sweep using the long edges as rails and make sure that I'm curvature matched across A and B. And let's take a look at this now with the environment map. So let's join it together, analyze, surface and environment map. And let's just remove this curve. Okay, so that's not too bad. So you can see that the shape looks pretty good there. In the environment map options, the fluorescent tube is a good type of environment to look at this type of surface, where we can see the shape of the blend that we've created really well with this. It's very good for showing up defects as well. Okay, so we can build a reasonably proficient blend fairly simply here, and all that we need to do now is to show the surfaces that we've got hidden. I can remove that back and then I can trim away the corner here, join my geometry together and then cap the back of this. Okay, so we now have a closed poly surface, and we can now either move this downstream into SolidWorks, or we can add more detail to this. In the second video in this series, we'll take a look at creating this scoop detail in the engine cover. This includes another less than straightforward blend condition, and also how we can maintain a seamless transition at the leading edge of the scoop where the scoop meets the existing engine cover surface. Thanks for watching, and I hope this video has proved useful.